Hello, let's continue our Sudoku adventure with Fresh Deli Meats by Jean. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these cages in the grid. You can think of these as extra regions if you want, because they don't have a sum. In fact, we know the sum. I'll tell you a little secret. The sum is 21, because they're 6 in size, and you can't repeat digits in them, so they're just going to have all of 1 through 6 once each, here and here. And then additionally, we have these German whispers in the grid, these lines. The way these work is every pair of digits on the line have to have a difference of at least 3. So if this was a 2, then this could be 5 or 6, and that's it. No other digit has a difference of at least 3. This is difference 1, difference 0, difference 1, difference 2. 2 is not at least 3. 5 is 2, 5 minus 2 is 3. That difference is at least 3. And 6 minus 2 is 4, which is also at least 3. All right, now once we place this digit, notice how these two also need to have the same pattern. So difference of at least 3. This could be a 1, 2, or 3 in this case. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. There is some geometry we can do here. This given 3 here is a little interesting because we know that this killer cage needs a 3 in it. And this 3 says not these 3. So it ends up down here, which then puts a 3 down here. Now, 3 is a little bit special for a German whisper. So is 4. 3 and 4 are what you need to watch out for because they only have one buddy. So for example, if there was a 3 here, then there's only one digit that's at least 3 away from 3, and that's the 6. And so the 6 would end up here, but it would also end up here because both of these pairs have to do it. Now that is legal, but it's restrictive. So we got to be careful about that. With the 3 here, that means there's no 3 here. This was for the box, but it affects the cage. So 3 is either here or here, which is interesting, but I can't really mark that right now. All right, I wonder if there's any coloring I can do here. So what do I mean by coloring? Well, I'm going to go purple, green, because I don't know if purple is low or high, but let's say purple was low, low being 1, 2, or 3. If purple were 1, 2, or 3, and we're ignoring any Sudoku here, if purple were 1, 2, or 3, then next to it, we can't put another 1, 2, or 3. All of them are far too close to another 1, 2, 3. The biggest difference I can do is 3 minus 1, which is 2. And so I can't be in the 1, 2, 3 range. I have to go into the 4, 5, 6 range. So we call this low, this high. And now once you're high, you can't do 4, 5, 6 again. You have to go back down to 1, 2, 3. So you're always bouncing back and forth, low, high, low, high, low, high. But we don't know if purple is low or high, but we do know that green is the other one. And so there's going to be 3 purples and 3 greens in every row, column, box, and within these cages. And that can sometimes help spread the coloring. Unfortunately, we don't really have enough German whisperage going on to really help with that. Obviously it means these 2 aren't 3. We already knew that these couldn't both be 3. But they could also be neither of them could be 3, and that would be fine too. A 3 here would mean both of these are 6. A 3 here would mean this is 6. Unfortunately, a 3 here doesn't do anything. Same with a 3 here. Okay, I'm not sure if any of that's helpful right now. So what do we do? We know these 2 are the same color as each other, the same low or high. I'm just trying to state what we know. This is different. Is there anything with geometry here that's interesting? Whatever this digit ends up being, so these can't be okay, so this can't be a 3. Right. Sorry, let me go over my thought process a little slower because I skipped ahead, but the conclusion is this can't be 3, and that's important. Whatever this digit is, let's actually use our letter mode here, and let's call that A. So whatever this digit is, we're going to call it A. Where can A go in this box? Well, it can't repeat in the cage, and it can't repeat in the column. So A ends up being in one of these 2 cells. Oops, A. If A is in one of these 2 cells, then it can't be here. A ends up down here somewhere, right? Importantly, that means these 2 are not the same digit. If these 2 are not the same digit, then I cannot make this a 3, because remember, 3 makes both of these the same digit. They both have to be 6. And now, if you see, there is nowhere for 6 in this box. So this can't be 3. That places the 3 here. And then now there's a 3 in one of these two. Oh, and this can't be 3 because of the cage. So the 3 is placed here, and that places a 6 here. Okay. So how do we follow up with this? There is a 3 somewhere in here. Oh yeah, and it can't repeat in the cage. Sorry, 3s are important here. It can't repeat in the cage. So that's not a 3. And then now 3's up here somewhere. And this finishes the 3s. One of the, either like this or like this. Now if this was a 3, these would both be 6. But we don't have like the same... Oh, we do have the same geometry. This cannot be the same as this. Because it looks in here and it can't repeat in the cage, right? So one of these two. So it's the same logic, meaning this can't be 3. And that finishes our 3s. Okay. Very nice. I don't know if I need to keep these colored. So what's next? The 6 probably. 6 ends up in one of these two in this cage. Because the cage needs a 6. And they can't go here. It's the same thing that this 3 did. So 6 ends up in one of these two, which then puts a 6 in one of these two. So we know at least one of these is a 6, I guess. So we can't double up the 6 here. 6 is very open, though. 6 can be with 1, 2, or 3. It's the most open German whisper number, along with 1. Is there more geometry I can do? These 3 digits are the same as these 3 digits. It's kind of one way to think about that. These are the same as each other. So yeah, they're not 6, they're not 3. 3's already placed. Is there... Do we want to think about 4 maybe? Because, okay, yeah, we know this can't be 4 and this can't be 4. These aren't 3, 4. They're 1, 2, 5, 6. Is something we should have baked into that. Because again, if this was a 4, this would be double 1, and there'd be nowhere for 1 in this box. And if this was a 4, this would be double 1. There'd be nowhere for 1 in this box. 1, 2, 5, 6. It doesn't really help that much. Yeah, I'm not seeing a huge restriction on 4s. Okay, maybe I should get rid of this color. Maybe there's something else to do with coloring. Maybe I should try to trace around a little better. So let's use a green here. Let's call this digit green. We know green's in one of these two. That points in here, meaning green is somewhere down here. But like, I don't know how to continue that, I don't think. We know green's down here somewhere, I guess. That's really not super helpful. And then this digit here could be green. Oh, no, these aren't the same color as each other. Yeah, these aren't the same low, high. You go low, high, right? Low, high. Or the other way around. So this is a different digit that ends up in one of these two. And thus it ends up here. And it ends up here. So it's symmetrical. So this counts for 2 out of the 3 digits that go here, is this digit and this digit. Don't know what to do about that, though. What's our next step? Okay, so we know that these 3 digits end up here in this box, because they can't repeat here. So that means that there's a purple in one of these two. Ah, so purple is placed in this cage. Right, these can't be purple, this can't be purple because it's green, and this can't be purple. Remember, we know these aren't the same digit as each other because of this German whisper line. They aren't the same parity. So this has to be purple, and then that actually places this purple. And then green should do the same thing. The only place for green in this cage is right here. And so this isn't green, placing this green. Okay. And so green is up here somewhere. We know green is not 3. All our 3s are placed. And so then purple is one of these two. We do more with that. What about this digit then? So if we call this blue, we know that this is actually a blue-purple pair. And now can we say that this isn't blue? You know, I think it could be blue. In fact, I think it must be blue because these can't be blue. Interesting. Oh, is the conclusion we were supposed to make is that these 3 digits are these 3 digits in the same order? It's quite possible we were supposed to conclude that. I think we've now proven it in a very non-straightforward way. But yeah, these 3 and these 3 are the same digits as each other in the same order, which is kind of interesting. There's probably some clean way to prove that. These 2 blues look down, this blue looks in. So this is blue, making this purple. So this can't be purple anymore. Now this can't be purple. So this is our purple. And then we can probably do the same thing with green then. How did we do that? It has to do with blue in this box probably. Yeah, this is blue. This is green. Oh, sorry, I meant to get rid of the white. So that can't be green. And we should be able to do more. Maybe. Blue in this box. Yeah, blue in this box goes here. So this is green. And this is green. There we go. So we finished the blues and greens. We don't know what digits they are, but we finished them. Okay, and we know that these 2 digits are the same as these 2 digits, and we know the order because these aren't the same. So if we make this orange and I guess red, then this can't be red. So this has to be orange, and this is red. I'm going to make all the 3s gray, just kind of fade them out a bit because they're done. We'll just use gray for that color. So yeah, red looks down, that's red, and this is orange. And then this red looks down, making that red, and this is orange. So now we know red is 6. So these are both 6. And so now orange has to be a 1 or a 2 by the German whisper line. So we can just put 1, 2 in all of the oranges. And that means blue has to be 4 or 5. So it has to be a high digit. And then purple has to be the other 1, 2, because 3 is gone. And then green has to be the other 4, 5. Okay. So this is our red 6 for the column. Oh, this is our orange, 1, 2. This is a red, oh, we know red 6. And this is our orange 1, 2. And there must be something with German whispers here that, yeah, okay, so this can't be 4 because we know these are different digits, and 4 would make them both 1. So blue is 5. Blue or you are 5, which makes green 4. And now we have to resolve the 1, 2 in some way. It's the German whisper. This 4 tells us that orange is 1 and purple is 2. Nice. Cool coloring puzzle, Gene. Had to individually color each cell, but I think the key deduction is that these 3 were the same as these 3. And you know what? That's actually a really easy deduction to make, which in retrospect is that these 3 are the same as these 3 due to normal 6x6 roping, because these 3 digits had to end up as these 3 digits in this box. And if these 3 are the same as these 3, that means these 3 are the same as these 3 because of the cages. So that is what I missed for a while. Okay. Really neat concept. Enjoyed it? Let me know how you did. If you enjoyed it, why not leave a like, subscribe, and a kind comment below.